These are the examples for Geometry B, Credit 2, Lesson 11.1. Lesson 11.1, we're going to be talking about dilations. Dilations is uh, another type of transformation. Remember, we've talked about um, translations, we've talked about reflections and rotations. Dilations is another type of transformation where the object is the same shape but not the same size. It's either getting bigger or getting smaller. And so, first of all, that's what actually we're going to talk about an example for problem one. It says, which of the following scale factors for a dilation indicates a figure is getting bigger? So a figure is getting bigger when the scale factor is greater than 1. So the scale factor is greater than 1. So any number greater than 1. So some examples of those would be like 4, 7, can even be a decimal, say 3.8, 6.25, or even a fraction. Now you might think, first thought, you might think, well, fraction, isn't that something like it's part of the whole, like less than 1? Not necessarily. If we have an improper fraction where the numerator, the top number, is bigger than the denominator, so like 3/2, 5/3, or even 9/4 is a few examples. So any number that's larger than 1, any scale factor larger than 1 is going to make the figure bigger, make it larger. All right, so now getting smaller is when our scale factor is less than 1, and it does need to be positive, so I suppose we should say greater than 0 and less than 1. So between 0 and 1. So between 0 and 1 would be any decimal in the form of 0 point something, like 0.2, 0.5, 0.9. Those would all be examples of numbers, scale factors that are between 0 and 1. Also, fractions, yes, but that would have to be a proper fraction where the numerator is smaller than the denominator. So, for instance, like 1/4 or 2/3 or even 11/12 would be another example. Again, where the numerator, the top number, is smaller than the denominator. So, on each of those, on 1 and 2, it says select 2 that apply. So on number 1, you're looking for 2 numbers that are larger than 1. And then on number 2, 2 numbers that are between 0 and 1. All right, so that's it for the examples for 1 and 2. The example for number 3, 3 and 4, actually, we should put up here. So this is for 3 and 4. And so for 3 and 4, they give us 2 figures. They give us the pre-image ABC. And remember, we know this is the pre-image because this does not, that figure does not have the little apostrophe marks, which we read as prime. So this is triangle ABC. This is triangle A prime, B prime, and C prime. So what they want us to do for number 3, but let's separate these. So example for number 3, they want us to give the scale factor. And so what we need to do to find the scale factor is we need to divide a pair of corresponding sides. And so we're always going to divide the image by the pre-image. So where we end up with divided by where we start. And we can take any pair of sides. We could use the A and B side, B and C, or even A and C. It's easiest if you pick a side that's either horizontal or vertical. If it's slanted, that's a little bit more work. So we're going to choose A and B. And so let's go ahead and take a look at that. So we'll do A and B. That works. So what we're going to do is our image, the primes. So we're going to divide the length of A prime, B prime by the length of AB. So A prime, B prime, we count the spaces. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So A prime, B prime has a length of 12. And AB has a length of 1, if you can see it in there, 1, 2, 3, and 4. So we divide 12 divided by 4, and we get a scale factor of 3. In other words, the length of this side of our image is 3 times as large as what we started out with on our pre-image. Remember, this is the pre-image, the triangle that we start with. Next question, they asked for the center of dilation. So the center of dilation, what we're going to do is connect the corresponding points. We'll use a blue pen for that. Let's start with the B's. And what we're looking for here is a point where all 3 of these lines, so we're going to connect the A's, the B's, and the C's. Now, I wanted to start with the B's because that's a little bit more clear in what we're doing. The C's are all going to be, and the A's will be on the same line. So here's C prime. We connect those. And then here's A and A prime, and we connect those as well. That kind of ends up being on the same line, doesn't it, as C and C prime? But that's okay. What we're looking for is the point where the line of B and B prime, C and C prime, and then A and A prime where they intersect. And that is our center of dilation. And so they appear to intersect right here at the origin. And so our center of dilation, this is, let's write what this is. Example for number 4. So our center of dilation is at the origin, so that's the point 0, 0. All right, so, and that would be our answer for number 4. All right, so that is it for the examples for 3 and 4. Now we're going to take a look at another example. It's going to be kind of a similar situation as 3 and 4. But let's take a look at it and we'll talk about it. So let's go ahead and get rid of all that. And this will be the examples for 5 and 6. And let's see if all this fits here. So we're going to have points, and we'll do, once again, we'll start with our pre-image. So it's going to take a second to draw this. So let's go ahead and do that. And we've got 5. I want to make sure we get this all right? -4 and 4 is here, and -2 and 4 is up here. All right, so there we go. There is our pre-image. So this is also good. Now, of course, the other one we had that drawn before we started the video, but this one you're kind of getting an idea. It's very clear the figure that we're starting with. And so we're going to connect all of our points here. And there we go. All right, so that's our pre-image. And let's go ahead and label this. We'll use the same letters, A, B, C, and D. Similar letters as we used in the last figure. All right, so now, changing colors of the pen here. Let's see, we've got 0.5 and 6. That's going to be B prime. -3 and 6, that'll be A prime. And here we have 7.5 and -6, that'll be our C prime. Then finally, -6 and 6 will be D prime. All right, so let's go ahead and connect those. We're about ready to start here. And this is the last, I believe it is, the last couple of problems for this lesson. And we're doing this one, even though it's similar work. We're doing this to illustrate what you're going to see on this example is the importance of counting carefully. Wish we had a little bit. Well, that actually works. Probably need a longer ruler, but I think we're good. Okay, so we have our pre-image A, B, C, and D. And we have our image A prime, B prime, C prime, and D prime. So what we want to do is find, first of all, the scale factor. That's number 5. And again, we're going to try and stick with either horizontal. Well, there are no vertical sides here, but we definitely want to stay away from the sides that are slanted. So like the BCs and the ADs, we want to stay away from that. All right, so let's take a look. Let's use AB. So we're going to divide our image, the length of AB, by our pre-image. Remember, pre-image is the one you start with, and that's AB. So let's go ahead and count here. We have the length of A prime B prime is 1, 2, 3, 4, 5, 6, 7 and a half. And this is kind of what we want to emphasize. That point there, if you can, maybe hard to see it, but it is in the middle of the square. So that is a length of 7 and a half, 7.5. Now the length of AB on our pre-image is, it looks like those points are right on grid lines, so that'll be a little bit easier. 1, 2, 3, 4, 5. So very important to notice, though, as we did with the image here, that if a point falls in between two squares, we don't round it. We have to say, well, that looks like that's a half, and so that's why we had 7 and a half there. So we divide 7.5 by 5, and we get 1.5. And so our scale factor is 1.5. So each of the sides on our image, the figure that's drawn in black, is 1.5 or 1.5 times larger than its corresponding side on the pre-image there. All right, now for the center of dilation, we do the same thing. We're going to connect corresponding points, so the A's, the B's, the C's, and the D's. Now you might look at this and kind of have an idea already of where these lines will intersect, but let's see, maybe not. Let's see. Now, how long do you have to draw these lines? Well, obviously to connect the points, and then far enough so that you can see what that point of intersection is. So there's the A's, the B's, and then the C's will be right there. You'll see I'm going maybe a little bit longer to where they intersect than to where they intersect. And now the D's. And there we go. All right, so this one, you can see that all four lines once again intersect here right at the origin where the X and Y axis meet. And so once again, our center of dilation is going to be 0, 0. Because all four lines, the A's, the B's, the C's, and the D's intersect at the origin. All right, so that is it for, just double checking here, but I believe that's it. That is it for the examples for lesson 11.1. So again, pause, rewind the videos. Again, we've talked about transformations a little bit throughout the year. We dealt with it first semester, and I think we even mentioned dilations. We dealt with that at one point briefly. But here we're seeing it a little more detail, finding scale factors, center dilation. And so again, pause, rewind the videos. I'm sure you'll do great with the work. And until the next video, take care and God bless.